Alrighty, so first thing, let's go. First thing we need to do.
Can we have members of the drill team please go to the lecture hall? Drill team to the lecture hall.
Alrighty, so questions on, I guess it'd be what, 9-8, 9-9, right? So it is, I don't have the date, 9 what, 29?
Yep.
Right? No, 28?
29.
28 or 29?
29.
9/29? Oh yeah, yesterday's my wife's birthday. It's the 28th.
My sister's birthday.
Freestone.
Number C on 9-9.
Number C on 9/9.
Wait,
Letter C on 9-9.
it's not 9. Like what? What month is 9? That's like September.
Oh yeah, I don't know why I'm thinking 9. Thanks, yeah. It's 3. But why you late?
You like skipped or
I left my
something?
house too late.
What?
I left my house.
Oh, okay. Yeah, that would suck. We'd just be getting started, huh? So you said 9-8 or 9?
9-9.
9-9, number C? The negative 5 pi 6? Alrighty, so, yeah, let me write something so it's got something to focus on. Alrighty, so C says negative 5 pi 6, right? So what I would do is I would go and I'd have to figure out where negative 5 pi 6 is. And negative means I'm going this way, right? And I believe negative 5 pi 6 puts me right there, doesn't it?
Yeah.
Negative 5 pi 6. Now, what that does is that creates this triangle. Because remember, I always create it with the horizontal. Now, if that is negative 5 pi 6, then what is this? But what is it? Nobody? Isn't that a 30-degree angle? So if I divided that into 6, wouldn't that be 150? Then that'd be 130, which would give me my 180, right? So if that's a 30, right, what is this side over here? So I know my hypotenuse is 1. What is this side, though?
Oh, like from the circle thingy?
Oh, yeah, from the circle thingy. Circle thingy will help you answer all these questions.
Isn't the top side 1/2 and the left side's rounded 3 over 0?
Well, that's what I'm asking right now.
And that's what I thought.
So you're saying this is what?
1/2.
1/2?
Or is it switched? Is that a radical 3 or 2?
I'm asking
Oh,
you.
it's negative 1/2.
It's negative 1/2 is right here.
No.
No,
wait.
negative.
Negative radical 3 over 2 and then negative 1/2.
Which is which?
It's like
Negative radical 3 over 2, and then.
Is here?
No, it's like the little thing that's like the XY.
Yeah, but remember, what's this?
Oh, that one's negative 1/2.
And that's my y, right? And then this is my negative root 3 over 2, isn't it?
Yeah.
Right? So if it wants all those ratios, I'm going to go the sine of theta, the cosine of theta, and the tangent of theta, right? Well, this and this are going to give you the exact same thing. So I'm going to look at my 30. I'm going to say, well, what is sine?
Opposite over
So I'm going to go opposite over hypotenuse. That's going to be negative 1/2 over 1, which is just what? Negative 1/2, right? Cosine is adjacent over hypotenuse, so that's negative root 3 over 2 over 1, which is just negative root 3 over 2, right? And then the tangent of theta is opposite over adjacent, which gives me negative 1/2 divided by negative root 3 over 2. Now, how do I do this? How do I take negative 1/2 and divide it by negative root 3 over 2? Yeah.
Wouldn't you cancel out like the like numbers?
Well, you do, but what to do that, you're going to invert this and then multiply. So what happens is this, is you end up with negative 1/2 times, when I invert this, I get negative 2 over the square root of 3. Well, my 2's reduce out, leaving me with 1's, right? And negative 1 times a negative 1 is 1. 1 times square root of 3 is the square root of 3, right? But what's wrong with that? I can't have a radical in the denominator, so I'm going to rationalize root 3, and I'm going to get square root of 3 over 3, so that's going to be the square root of 3 over 3. And then to do the other ones, I'm just going to do what? Yeah, flip that. So that one's going to be what? Negative 2. The secant of theta is going to be negative 2 roots of 3 over 3, right? And then the cotangent of theta is just square root 3, right? So when I inverted that, I would have had 3 over the square root of 3, right? Well, when I rationalize that, root 3 and root 3, that gives me 3 roots of 3 over 3. What will those 3's do? Reduce, and that's going to leave me with the square root of 3. And you would have had that for the first 3, then that, and that for the second 3. That makes sense?
Yeah.
Okay. Did you watch these while you were gone?
I watched them when I got back.
Okay. Whatever. Good job. Yo,
So is tangent opposite over adjacent or adjacent over opposite?
it's a TOA. Tangent is opposite over adjacent.
Oh, okay, yeah. Okay.
Yeah, if you screw them up, that could be a problem. Yeah, it's opposite over adjacent. Okay. Anything else on... Nobody had anything on 9A? That was easy, the coterminal part. Okay, what about anything else on 9-9? I mean, they're all the exact same to that problem, aren't they? Just with a different triangle. And what you did find is that every triangle matched, or every angle matched one of those triangles, right?
Yep.
Which is why it's so important to have the unit circle chart done. Yeah.
Can I pick up on 9.9G?
9.9G. So negative 7 pi halves. So negative 7 pi over 2. So where does that put me?
At 270 or something, I'm pretty sure. Actually,
I don't think so. If it's a halves, it's going to end on a line, isn't it? Doesn't negative 7 pi halves, isn't that 3.5 pi? Isn't that negative 3.5? Well, that's 2 pi. That's 3 pi. That's a half a pi. Doesn't it end up right there? Which gives me 0, 1, right? Well, that's why it was important to know that little right here. This is where this come in handy. Right? Because anytime I land on a line, all I've got to do is my y value over my r. So, if I have that, because I can't do what when I land on a line? I can't do a triangle, which is why I believe the other day I showed you this, didn't I? Did none of you write this down?
I did.
Oh, okay.
Oh.
Okay, okay. So when it says the sine of theta, well, sine is simply y over r. Well, what's my y? What's my r? What you'll notice is that any time I land on a line, you're going to get one of like 4 answers. Right? You're going to get 1, -1, 0, or undefined. That's pretty much your only 4 options. Good job. Does that... Can you finish the rest of that?
yeah.
Okay. But does that make sense? Isabel, do be quiet.
Sorry.
Don't come in late, then make a bunch of noise.
Yeah.
Yeah. It's like 2 strikes already.
Sorry.
See my point?
Yeah.
Yeah. We've never had this many people absent, have we?
Yeah,
We have?
it was like 9 people.
Wow. That's frustrating. All right, well, if that's it, we're going to go on to section 910. Man, this chapter is long. Goes to 12. Yeah. All righty, so we're just going to keep right on rolling along, though. So it is still 3:29. We would hate to skip summer. What the hell?
3:32.
I'm just making days up. We're on the 32nd day of March. Wow.
Yeah, really good imagination.
Yeah, I don't know what's going on there. 3:29. All right, so this is SM2H unit. We're 9.10, and this is 5th period, okay? And we're going to do this. Our objective is going to be able to use the unit circle to find exact ratios. Alrighty, now what we're gonna do is we are gonna do similar to what we did the other day, but not. Well, yeah, it's pretty much the same stuff. Let me look at something really quick. So we don't have school Friday, right?
Nope.
We're only gonna have class today and Wednesday, right? I don't think Wednesday's a short day. No. No, it's not.
What?
Because it's the 5th, Wednesday. Hey, I don't recall saying to just talk. I said, give me a second, I'm looking at something.
Sorry, it's just my favorite.
It's what?
It's my favorite hobby.
Well, that's her favorite hobby too. Can I sit you two together?
Maybe.
Well, you already did, so.
Well, I can fix that. I know a guy that pretty much.
Is it the guy with the name on the wall?
That's the guy with the name. Yes. I'm glad you pointed that right out.
Mr. Denton. Denton.
What?
Yeah, it's like Denton.
Yeah, one of my students made that for me. We'll be all right. Okay, so. Oh my God. Do you remember how I said earlier it was like 2 strikes? Well, we're gonna call that a foul tip. Okay, then we might have to go have a chat with your mother.
Oh no.
Yeah, shut it! Damn. Alrighty, now, so what we're going to do is you're going to take and they're going to give you, and it doesn't matter what it is. So let's say I gave you the secant of pi thirds. Let's say I gave you that, okay? And what it says is simply says use the unit circle above to find the exact value of each of the following. Now they're just being really specific. So what I would do, if I want to find the secant of pi thirds, I first got to go and figure out what? Well, I would find out where is pi thirds, right?
16.
Okay, so I would go and say, okay, I know that pi thirds is right there. Is that what you're telling me? Yeah. Maybe a little more, but that's the idea, right? And this is 60 degrees.
All members of wind ensemble and drumline needed in the lecture hall.
Oh, I did not realize.
Drumline to the
Is
lecture
today
hall.
test day? Oh, shit. Did you really just say you know it? Like it's a good thing?
No, I'm just saying that.
What the hell, between you two, are you talking again?
I'm not talking.
Did we all hear his voice?
Yeah.
Uh,
Oh my. I was laughing.
oh, that's different. Is that what you're saying?
Yeah.
Oh, okay. Now, so, if that's 60, do I know this? What? Well, what's this? Now, what's this?
1.
That's 1, right? Okay, correct? So what else do I know here? The vertical one is root 3 over 2. And what's this one? 1/2, right? So I know that, correct? And I gotta go remember, and I gotta say, well, what was secant? Secant, it's not cosine, but it goes with cosine, right? It is the opposite of cosine, right? And I know that cosine is CAH, right? For SOHCAHTOA, right? So cosine is adjacent over hypotenuse. So secant is equal to hypotenuse over adjacent, right? So now when I want to know the secant of pi thirds, I'm going to come over here and say, well, what's my hypotenuse? 1 divided by what's my adjacent? 1/2, right? Now, how do I do this? No.
You can't.
Well, what is 1 really? Isn't that 1 over 1?
Yeah.
What do I do with this? We just did this. I'm going to times it by its inverse, which is 2 over 1. So the secant of pi thirds is just... No. Isn't it 2 over 1?
Yep.
Which is just 2? And that's exact. Okay? So if I wanted the cosecant of negative, I don't know, let's go negative 5 pi over 2, okay? Well, the cosecant of negative 5 pi over 2, I've got to go and figure out, well, where is negative 5 pi over 2? It's on a line. And it's where? So I'm going to go like that, right? Isn't that where that's at? 'Cause isn't that negative 2.5 pi? Right? And what do I know about these? It's on a line, so I just have to know my point. And that's going to be what? 0 and -1, correct? Now, cosecant is the opposite of what? Sine, right? And what do we know that sine is? Whenever it falls on the line, I gave you that chart, right? What's sine? It's y over r, right?
Golf needed in the lecture hall. Girls golf to the lecture hall.
It's y over r, correct? So this cosecant is going to be r over y, right? Well, what's that going to be for this point then? Well, what's r? 1 over -1, which is -1. Yo.
Okay, wait. Does that when you like does SOHCAHTOA tell you like what's opposite, adjacent, opposite?
What do you mean by that?
Well, like when you write it out, like does it tell you which one's which?
So sine is opposite over hypotenuse.
Oh my, you're kidding. This whole time it's okay. Yeah, thanks.
Wait.
I did not know that. I didn't know that.
Yeah, neither did I.
That's just
I thought you had to just memorize
You
it.
didn't know
What?
That's just 2 days.
I'm pretty sure I covered that, didn't I?
I know. You've been telling us a story about the guy that was like.
Oh, yeah, you never told us that. You never told us.
But you never told us what it stood for.
I've been learning like this
So
since
I
like
know
sixth
it's
grade.
Yeah, I remember it was just.
No, I know I wrote this. I wrote S equals O over H.
You did.
No, we learned this. You just told us about the second.
I call
No,
bullshit.
he
Just guess what I have.
You have not.
You did it. You did
You
it.
just told us the story and then.
Hey, are you talking again? With your face mask down?
It's true, you told the story and then you were like, hey, get into the assignment, and then you didn't tell us what it said.
You did.
Just a minute.
You wrote Sokotoa down, but you didn't explain it.
What day was it? Who has the...
It was a fat.
I don't know, it was like a year ago.
It wasn't 9.
It had to be 9 what?
Was it in 9-1? I think it was in 9. It was in 9.
Like 92.
9-2?
Yeah.
Girls lacrosse to the lecture hall, please. Girls lacrosse to the lecture hall.
It's in 9.2.
Yeah, Leslie has it. She copies everything down for I thought you were just gonna rip it when I'm gonna be honest. I was like, what is wrong with you?
Oh! Shut it! I do. It's right there.
Is this our
No,
class?
that's
Yeah. It's her notes.
Did you learn that before this year?
He said it. I just wrote it down.
Oh no!
Look.
It's all the kids.
Paul, I do not remember this.
Yeah,
Well,
yeah,
I don't care if you remember. Dude, leave. Yeah, I wrote it down right here. Sign is opposite over hypotenuse. The O and the H are right there.
Part of that.
Look at it.
It's
You guys are needy. Alrighty, so we gotta finish this. Oh no, we finished that one. Alright, let's do one more. Let's do a couple raisy handies. Let's do so let's do the sign. I want to do the sign of
72.
7 pi 7 pi thirds. The sign of 7 pi thirds. I want the exact ratio for the sign of 7 pi thirds. And let's go for 15 hands. 15 hands. One. Two. Three. 4, 5, 6, 7, 8, 9, 10. How many did I say?
15.
15. I need 5 more. Remember your numbers. 11. 4 more. And a haircut. I need 4 more. Let's go. 12. 13, 14. Do you see this look on my face? Do you see this look on my face? Hey, shut it. That's you two I'm looking at. Whatever you're saying that's funny, that's making her laugh, shut it. I need one more. Bailey, keep your face mask up. 15. Alrighty, who is 10? Garrett, what do you got for me?
So I like.
Well, yeah, let's do this. Where is 7 pi thirds at? Quadrant 1? So, we already did this?
Yeah, that's like the exact same size.
So we went right to there. Is that what you're telling me?
Yeah.
Okay. So 7 pi thirds and pi thirds end up being the same thing, right? So what's your ratio? We did the signs. We actually we should have a different number here, right? Okay, but so you did
Radical 3 over 2.
root 3 over 2, is he right?
Yeah.
Just like that. Okay? Now, let's say I wanted the cotangent, right? We ready? The cotangent of negative, let's go negative 750.
Oh, shoot.
Cotangent of negative 750. Let's go 20. I want 20 hands. Write down your number if you have to. We're finding the cotangent of negative 750. One. Gotta have 20. 2. 3. 4. 4, 5.
No, wait, I'm not.
4, 5.
Is it, so what's the cotangent? Isn't it opposite over
No. Tangent is opposite over adjacent, so cotangent is
adjacent over opposite?
adjacent over opposite.
Okay.
So we would be, Freestone, what number were you? 5. So 6, 7. We're going to 20. I'm going to need a bunch of you. And I'm at 7. William. Bryce. Keep your mask up. So you're going to be 8, 9, 10. Halfway there. 11. 12. 13, 14.
I mean, I have done nothing, and I'm trying to.
15. 5 more. Let's go. 16.
All members of boys tennis to the lecture hall. Boys tennis to the lecture hall.
Mr. Denton's tired. Or he's just bored.
Tired of our crap.
Yeah, that would be more like it. Am I not going to get 4 more?
I'm trying.
17. 3 more. Let's go.
Hey, maybe I got it.
18. Dos más.
Okay, well, we're not gonna blame it all on you. Succeed or fail. If my number gets come and say no.
19. One more. 20. Alrighty. So, who was 10? What do you got for me, Bryce? Well, first off, tell me where negative 750's at.
On the 330.
So I'm going to go here. Right?
Go around one, yeah.
That's 360.
Then around another.
Around another. All the way.
Yeah.
Okay.
And quadrant 4.
Basically right there. Would that work?
Yeah.
Okay.
And then I found the tangent, so it's 1/2 over negative square root of 3 over 2. And then I inverted the bottom one and times it to the top.
So you found. So is that the tangent or is that the cotangent?
That's tangent.
Oh, so okay. So then you went. 1/2 times 2 over negative roots of 3.
Yeah.
Okay.
And then I got negative root 3 over 3.
Negative root 3 over 3. Okay.
That's it. I think.
That's it. Okay, but I wanted the.
Oh, wait.
That's the answer?
Yeah.
That's what I got.
So instead of finding, you actually found the tangent. Because I wanted the
Okay.
cotangent. You see what I'm saying? So this is cotangent. Is that the answer?
Yeah.
Yes or no?
Yeah, that's what I got.
Who got that answer? Well, let's look at it then. So this is what I would have done. I would have done exactly what Bryce did. I would have figured out where negative 750 is, right? And it's the same as negative 30, correct?
Yep.
So that's negative 30. That's 1. That is negative 1/2. That is root 3 over 2, right? Okay, well, cotangent is x over y, right? Isn't it x over y? Because tangent's y over x, isn't it? Didn't we just talked about this, right? Tangent's y over x, right? So isn't cotangent, it doesn't matter. It still works. Cotangent's x over y, right? So I just took my x value, which is, no, you are backwards, I think. Because isn't this my x value? Isn't it root 3 over 2? Divided by my y value, which is negative 1/2, right? So I'm going to get root 3 over 2, but now I'm going to times it by negative 2 over 1, right? They're going to reduce out, and I'm going to get just negative square roots of 3.
Let's go.
Anybody else get negative square root of 3? That's the answer. The rest of you found what? Tangent. Yes.
So, I don't know how I got the right answer, but I saw negative 750 and I added positive 360s to it until I got a positive number and then it got me to 330.
Yeah, well, because what you would have found is you would have found positive 330.
Yeah.
Well, but what you need to realize is positive 330 and negative 30 create the same what?
Angle.
But the same triangle, which is going to give you all the same values.
And then
Which is why, if you go back to this, watch. So if I did the sine, it doesn't matter. Let's say I did the sine of 30, right? And I did, we're negative 30, right? So I did the sine of negative 30, and I did the sine of 330.
There's a glare.
They're the exact same thing because they create the same triangle. I'm pretty sure it's negative square root of 3. Again, how many of you got that? Okay, we're doing one more because there was some confusion. So let's do this. Yeah. So let's do the secant. We're going to do the secant of
We need all members of the baseball team to the lecture hall. Baseball to the lecture hall, please.
secant of 225. Everybody do the secant of 225. Now, what I notice is some of you keep referring to your unit circle That's why we did the unit circle. It's so you would refer to it. The more times you refer to it, the more likely you are to do what? To use it, to remember that stuff. Guess what part of the test is?
Oh, no.
The unit circle. I believe I said that, did I not? Drake, keep your mask up. Steger, keep your mask up.
Sorry.
Okay, we had a big long meeting about that the other day. If your teachers aren't making you keep your masks up, that's a problem. So we are 1, 2. I want 20 hands. Three, 4, 5. Six, 7. Do you want to be right here, like right in front of me?
Not really.
Okay, then shh. So 8, 9, 10. 10 more. 11. 12. 13, 7 more, 14, 15, 5 more, 16, 17, 18, 2 more. Dos más. 19, uno más. 20. Alrighty, who was 8?
That would be me.
You were 8? Okay, where is 225 at?
It's 45 degrees.
It's 45, right? And that's what's important. Understand that secant at 225 is really just a 45, 45, 90, right? So secant, I heard these two debating it, secant is the opposite of what? Cosine, right? So cosine is that, right? So secant is going to be hypotenuse over adjacent, right? So what's that going to be?
Negative root of 2 over
1 over negative.
So I'm going to go negative
roots of 2
roots of 2
over 2
over 2
over negative roots of 2 over 2.
over negative roots of 2 over 2. What's my hypotenuse in this triangle every time? 1. You did tangent or cotangent
Okay.
to do those two sides. So isn't it just 1 over negative roots of 2 over 2?
Yeah.
Which when I invert is going to give me negative 2 over the square root of 2, right?
Yeah.
But I got to rationalize root 2 and root 2. Hell. Which is going to give me negative 2 roots of 2 over 2, which is going to give me negative square root of 2. Just like that. How many of you got that right? Oh, that was a good job.
Hey, Dad.
Yeah.
Okay, so what's the opposite of sine and what's the opposite of tangent?
So remember, it's sine, cosine, tangent, right? What's this one? Cosecant, secant. Just remember, the one that you think it should be, it's not. Because they always think that cosine and cosecant, it's not. Sine goes with cosecant. cosine goes with secant, tangent goes with cotangent.
Because if you have that, technically,
Wait,
can't
what?
you just do it?
Yeah, it's just the, yeah,
And the
just,
Y's and the R's.
yeah. So what I do, and this is how I do it.
Okay. 'Cause that's-
Okay, I know that sine is y over r. Well, cosecant is just r over y.
Yeah.
And once I know them, it makes it easy. So if sine's y over r, cosine is x over r. Which means secant is r over x. Well, if tangent is y over x, cotangent is x over y. If I know my unit circle, it makes these way easier. Does that make sense? Yo,
See, wait, actually, never mind.
anybody else? Time is yours. Use it wisely.